Data is a critical determining factor in the performance of neural networks for autonomous systems such as self-driving cars and drones. Creating 3D scenes often requires a lot of manual effort that makes the data generation process expensive, time-consuming, and strenuous. On the other side of the coin, the real data annotation and cleaning requires extensive manual effort to label the data, which often leads in not-so-perfect annotations due to human errors. Rather than manually creating the entire world in the simulation, we take advantage of the real world that we have already created. We utilize the semantic, structural, and depth information from the satellite maps in order to create a high-definition 3D model of the entire cities and warp appropriate texture maps on this data. In this work, we present WorldGen, a generative simulator for various applications ranging from a drone flying over the city, through the city, all the way to the self-driving car views. Since we have the entire control over the 3D models, we have the ability to dynamically change scene lighting, weather conditions, and textures in our map. WorldGen can generate models of countless real-world cities in a simulation environment. Furthermore, to close the gap of neural network performance even further, we generate unstructured 3D scenes by importing a plethora of open source models and textures. We then apply variational UV maps that not only change the textures of the objects, but also vary them structurally. We exploit WorldGen to generate petabytes of data to better learn geometric quantities such as depth and optical flow. We improve the photorealism by utilizing Blender's ray tracing engine, dynamic lighting, variable depth of field, motion blur, and other real-world camera and motion models to our environment and generate annotations such as semantic labels, depth maps, optical flow, surface normals, stereo cameras, event cameras, and much more. We believe that the WorldGen will open new avenues for researchers to generate large amount of scalable data for different autonomy applications.